cloud seeding, you want it to rain, and if you're not careful, you can overseed the cloud and actually get less rain than you would have had if you hadn't done anything. Regardless of how you do it and what you're trying to achieve, cloud seeding is a legal and ethical nightmare. It is an extremely complicated legal process to go through if you are you'll probably end up in a very long and complicated legal process if you get involved in cloud seeding. Because you can well imagine that if you are a farmer, for example, and you attempt to use cloud seeding to increase the amount of precipitation on your farm, your neighbors are not very happy if then it doesn't, whatever rain the cloud might have produced falls on your farm and not on theirs. Similarly, if you perform some cloud seeding on a cloud and it ends up growing into a huge thunderstorm that produces hail and wipes out your neighbor's crops, this is a serious complication. As a consequence, cloud seeding is actually quite rare in the United States. There's only a small number of situations where, for example, on some Indian reservations, the tribe uses cloud seeding to enhance the precipitation over grazing lands. Or sometimes under conditions where there hasn't been very much snow in the mountains. States like Colorado will engage in cloud seeding to increase the snowpack over ski resorts. But overall, this is it's just not worth the work, not worth the legal jeopardy you put yourself into when you do cloud seeding. Cloud seeding is common in some societies that are less litigious than the United States is. There's a lot of cloud seeding in South Africa, there's a lot of cloud seeding in Russia, but in the United States it's just a legal and ethical nightmare to get involved in cloud seeding. There is one important application of cloud seeding that didn't work but ended up having an important influence on the history of meteorology, and that is the role of cloud seeding in hurricane modification. Especially in the 60s and 70s, there was this big idea that if we could use cloud seeding to weaken hurricanes, this would be an important way to protect the United States from damaging hurricanes. And the basic idea was that they were going to use some combination of cloud seeding and overseeding to weaken the eye wall of a hurricane in such a way that the hurricane would lose intensity. And it wouldn't have taken a very big change in the strength of a hurricane to make this worthwhile. By most estimates, if you could just reduce the speed of the winds by even 1 or 2%, it would prevent enough damage to make the whole process worthwhile. And so this was a big effort, especially in the late 60s. And after enormous amounts of work of trying to fly these planes through hurricanes and trying to take measurements and trying to do seeding and trying to do overseeding, what we learned is that we really couldn't control the hurricanes. There never was any evidence that anything that the scientists were trying to do to the hurricanes actually was modifying them in any way. And that makes some measure of sense, by the way. Most of the clouds in a hurricane have plenty of ice crystals, but the clouds are too big, it's hard to overseed them. Cloud seeding was never really a good strategy for hurricanes. But just by being out there in the hurricane and taking observations of the eye wall, as you see in this picture right here, and dropping weather instruments into the hurricane and so on, we took observations and we got data, and from this data we were able to make better forecasts. With these better forecasts, we've been able to save lives. Most people in hurricanes are able to evacuate long before the hurricane gets there, simply because the forecasts are so much improved. So nowadays we don't try to modify hurricanes at all, but we have hurricane hunter missions where the Air Force runs these reconnaissance missions into hurricanes. They take specialized scientific observations, and using these observations we make much better forecasts than we would have without the observations. So it's kind of an interesting little example here. The actual business of modifying the hurricane was a failure, but the business of what we do with the observations now has actually resulted in forecasts that save people's lives. So as you might have noticed, none of the different strategies that we talked about for weather modification really work all that well. They're either too expensive or too hard to control what's going to actually end up happening, or it takes too much energy to make them happen. In general, weather modification just doesn't work. There is one application, on the other hand, of weather modification that is used routinely, and that is for frost prevention. Frost is a huge problem if you are a citrus producer in Florida, particularly for oranges, but also for other crops. Now, frost is actually a fairly rare problem down there, but I mean, it just doesn't freeze that often in Florida, but when it does freeze, the damage is enormously expensive. Oranges are expensive. The orange trees take a long time to grow back if they are damaged. It's not that frost isn't a big problem for corn, or for soybeans, or for alfalfa, but oranges are extremely valuable, whereas corn is $2 a bushel. And as a consequence, in general, row crops like corn and soybeans and stuff, the farmers typically just take out some kind of insurance, and if a frost comes and damages their crops, they just collect insurance and replant. On the other hand, in the case of oranges and other citrus crops, because they're so valuable, the growers can afford to fight the frost. They can afford to take certain kind of measures that are going to reduce or mitigate the importance of frost. Now, frost is going to happen in Florida. Now, this is obviously not Florida with these mountains in the background. But frost in general is going to happen when there's a very shallow layer of very cold air near the surface. And so there's going to be a number of different ways you can fight this frost from happening. And one such way is what we call smudge fires. Smudge fires are built in these canisters that you see scattered around this orchard. That's actually a very small orchard, and the trees are very small in there. And on a night when they fear that there's going to be frost, they light the fires that are in there. Now, the fires themselves are not warming up the orchard. This is really about the smoke that's coming out of these fires. And these fires are designed to be extremely smoky, sooty fires. They produce a lot of smoke that hangs over the field. Why do they do this? Because smoke works very well as a greenhouse gas. Okay, smoke's actually an aerosol, but you know what I mean. Long-wave radiation from the ground that is escaping and cooling the ground will instead be absorbed by the smoke, and the smoke will then emit the long-wave radiation back down towards the ground, and it will keep the ground warmer on a night when you fear frost. So you light these fires, the smoke kind of forms like a blanket over your orchard, helping hold in the long-wave radiation and keeping the ground and the trees warmer than they would otherwise have been. This is a relatively effective way to protect your crops. It's expensive, but it is a practical method when you think about the amount of time involved in growing an orchard and the value of all the citrus crops on the branches. On the other hand, it does make a big mess. I couldn't find any quick pictures right now, but this smoke is very oily, and it covers the leaves and it covers the fruit. And as a consequence, smudge fires are not necessarily an ideal solution as to how to prevent frost, although it does certainly work. A more brute force way of fighting frost is what's called an orchard heater. And orchard heaters are exactly what they sound like they are. They are not there to produce smoke. They're there to warm the ground up and to warm the air up near the surface so that it doesn't freeze and the crops are protected. Now, this would certainly be your most expensive, most difficult way to keep the crops from freezing. There's the amount of heat involved to keep the air warm over your orchard is just enormous. But if your crops are valuable enough, or your orchard is small enough, or it's only going to be a degree or two below freezing, so you don't have to run the heaters all that much, this can be a practical way to protect your orange crops. Another important way to prevent frost is with a wind machine. And there's a nice picture of a wind machine in this ad on this slide. It looks like a windmill, but it's exactly the opposite of a windmill. Instead of the wind turning the blades, here the blades are like a big fan. It is actually creating wind. Now, what is the point of this? On most nights where frost is occurring in Florida, it's a very, very shallow layer of cold air near the surface, literally only a few meters thick. Even 20, 30 feet above the tops of the trees, the air is considerably warmer. Using a wind machine, you're trying to mix the warm air above the trees with the cold air down at the level of the trees, hoping to result in a temperature that is above freezing.